Now in question number 14, we are given a linear differential equation and from which we can find this function yx. Now in this integrating factor, it will be e to the power integral of 12 dx, which is e to the power of 12x. So we can write this as y into e to the power 12x into this integral e to the power of 12x into cos pi by 12x dx. Now we know that this integral of e to the power ax into cos bx dx, we solve it using by parts, and since this is a standard result, we'll directly write this as e to the power ax upon a square plus b square into a cos bx plus b sin bx. So we are directly going to write this as y into e to the power 12x, and here it will be e to the power 12x upon 12 square plus pi square upon 12 square into a cos bx. So there will be 12 cos pi x by 12 plus b, which is pi by 12 sin pi x by 12 plus c. Now we are also given initial value, which is when x is 0, y is 0. Now if we put x as 0 and y as 0, it will be 0. This is 1 upon 12 square plus pi square upon 12 square. Now this is 12 plus c. So value of c is minus 12 upon 12 square plus pi square by 12 square. So we can write this function y as y into e to the power 2x. It will be e to the power 2x upon 12 square plus pi square upon 12 square, 12 cos pi x by 12 plus pi by 12 sin pi x by 12, and then minus 12 square plus pi square upon 12 square. Now we'll divide everything with e to the power 2x. So here we get e to the power minus 2x. So our function yx, it will be 1 upon 12 square plus pi square by 12 square into 12 cos pi x by 12 plus pi by 12 sin pi x by 12, and then minus 12 into e to the power of minus 2x. So that's our function y. Now option D is, it is a periodic function. So this part, it is a periodic function. But e to the power minus 2x, it is non-periodic and it is a decreasing function. So this function yx, it is not a periodic function. So that means this option D, it is incorrect. Now option C is, there exists real number beta such that line y equals beta intersects the curve y equals yx at infinitely many points. Now if we take beta as 0, then basically we'll have this 12 cos pi x by 12 plus pi by 12 sin pi x by 12 equals 12 e to the power minus 2x. Now this left hand side, it is a periodic function, so it will be some periodic function whose value will keep repeating, and this 12 e to the power minus 2x, it is an exponential function whose value will decrease. Now these two curves, they'll intersect at infinite points. So that means there'll be infinitely many points at which this line y equals beta is going to intersect this curve y equals yx. That means this option C is correct. Now, if we differentiate this curve, dy by dx will be 1 upon 12 square plus pi square upon 12 square. Now this is pi minus sine pi x by 12, and here it will be pi square by 12 square cos pi x by 12 and plus 24 e to the power minus 2x equals 0. Again, this is periodic function, and again this exponential function will decrease, so there will be infinite points at which dy by dx is 0. And if dy by dx is 0, that means somewhere it is positive and somewhere it is negative. So it is neither strictly increasing and nor strictly decreasing. That means options A and B are also incorrect. So the only correct option in this case is this option C.